Hello, everybody. Yes, hello. Right, I think we'll just make a start. I know it's 30 seconds before, but that's an extra 30 seconds for me. So welcome to my talk today on the journey to W4 or WX. How hard could it be? And the funny thing is, I'd love to actually change a lot of these slides after Gabby's talk, because this is effectively his call to action, in practice, essentially. My name is Keith Stockdale, and I'm a senior software engineer at Rare. And I've been working at Rare since I was an intern in 2015. So I was an intern in 2015, and then went back to Queen's University Belfast in Northern Ireland to finish off my degree. And then I came swiftly back to work on the rendering and engine teams at Rare, and I've been there ever since. If you want to learn more about me, you can follow this link. There will be a lot of QR codes to links that I'm referencing throughout this talk. I like to reference everywhere I'm getting my information from. On this website, you can get links to my GitHub, my LinkedIn, and you can also read my blog. It's fairly active at the minute. You can read all about all the projects I've been working on, both at Rare and also in open source. And then you can also get a link to all of my talks that I've given up to this point. Now, if you've never heard of Rare, Rare is a lovely little Xbox game studio based out in the middle of England. So these are just some pictures that I took whenever I arrived one very frosty January morning this year, and I just thought it was a lovely morning to go and have a walk before actually going to sit down at my desk. But yeah, it's a fantastic place to work, really good culture, and that's probably the reason that we've been around for so long. We've been around for 40 years, so older than me. And in that time, Rare as a studio has made games like Battletoads, Perfect Dark, Conker's Bad Fur Day, anybody? Cameo, but the game that I'm going to be talking about today is Sea of Thieves. Now, I talked about Sea of Thieves at 2 conferences last year, and it was all about the journey I went through to upgrade from C++ 14 to 20. This is a link to the ACCU version, so this is the first time I gave it. And I always love seeing this thumbnail, because it is so wrong in so many ways. But it drove lots of views. It was a really popular talk. The things that are wrong here is that Sea of Thieves was never on 11. Never happened. And also, this thumbnail also implies that we went further towards MSVC C++. Half the talk is the very opposite of that. We wanted to get away from MSVC-specific code. Now, all of this was done. The whole point of this talk was just to talk about all the work we've been doing to improve developer experience at Rare. And to do that, we achieved more standards conformance, right? So we initially only had MSVC to compile with, but then we got the PS5 compiler whenever we made our port. So now our code is much more happy with both those compilers. One of the nice things that we got with that standards conformance was improved build time. And improved build time means less time building, which means more money, right? Because you're not spending as much money actually building. And it also fixed and found bugs for us. So up until C++ 17, this code will compile and it will run, and it will appear to work. But it doesn't. It will not print out hello BeCPP. It'll print out the memory address of that string literal. So whenever you go up to C++ 20, this is now a compiler error, because that particular overload is now deleted. So whenever you upgrade your standards version, you are getting a better language. You're finding more bugs at compile time, which is a huge amount of the reason that about what I'm speaking to today. And of course, if you upgrade your standards version, you get lovely new features as well, right? We all like the nice new shiny things. And one of the most used features that we've been using is designated initializers. And I just wanted to mention this great blog article by Matt Roper, put out earlier this year, and he talks about how it's probably the most useful C++ feature, C++ 20 feature, but it's almost never talked about. But it's just very innocuous. Like it's very uncontroversial, and yet it can lead to really nice APIs. So, fantastic. Now, why W4 WX? Right, why? Well, to talk about that, I'm just going to talk about the journey the code makes from the point that you write it to the point that you actually submit it. So the first thing you're going to do is you're going to give it to your compiler. So for us in Unreal Land, this is MSVC. And if it's happy with your code, it's going to compile, you'll get an object file, and then you can begin testing. And testing is a big thing at Rare. So the first thing you're going to do is just actually verify and write tests that it does the thing that you want it to do. And once you're happy with that, you're going to put it up for review, right? So somebody else can verify that it is doing what it should be doing, and that you're not doing very silly things, right? You're getting a second eye on it. And alongside a review, you're also going to submit it for a remote run. And a remote run is simply just a pre-commit check. So it'll just take your change list, and it will run that against our CI instance, just to make sure that you're not breaking other people's code, and that your code actually runs in every configuration and not just in your very specific dev environment. One thing I'll note here is the fact that as we are submitting more remote runs, that number is going up. Right? We're always writing tests for new code. You absolutely should be doing this. It is a very rare feature that gets through without tests, and you have to have a good reason for it, right? But in most cases, that number is going up, right? The other thing I'd like to note is that there are some red runs there. Never trust a test that has never went red, right? Never trust a job in your CI that has never failed either. This is catching actual issues for us. There's a good reason for us doing these pre-commit checks, these remote runs. It's catching stuff. Now, whenever you've got a green remote run and everybody's happy with your code, you're going to submit it. And you're going to get this lovely message as well. It's going to tell you when it's going to be validated, because a remote run's not going to run all of our tests. It would take way too long. It's just there to give us good coverage, to have some amount of confidence that you're not going to break stuff. But it could still break stuff in some cases. And this is telling you that you probably shouldn't submit code at 4 o'clock on a Friday, because that could break the build at 7 o'clock when nobody's there, and then people who come in early on a Monday are going to get very annoyed at you. So yeah, absolutely, you need to be just making sure that you're not going to harm other people. Now, whenever you submit your code, it's now going to be subject to the entire gauntlet. And we've got those gated on different triggers, and it takes about a day for your code to be fully validated if you include the performance test that we do overnight. Now, what is this all? Why am I telling you all about this? Well, it's all about talking about the cost of finding an issue. If you find an issue at the compiler stage, it is very cheap to fix. That compiler will tell you the line of code that the issue happened on, and it'll hopefully give you a good error message as well so you can actually go and fix it. If you find an issue at the testing stage, it's still pretty quick. It just requires a recompile and a rerun of your test just to iterate on it, but it takes a bit more time. And then whenever we're getting to the code review point, now you're taking up other people's time, not just your own, right? And you want to convince people that it won't take too much time to review your code so that people actually do want to do it and prioritize it. And then if an issue is actually found towards the end here, it's not just you and the reviewer that you're inconveniencing, it is the entire studio, right? Because we're not actually able to do anything if you break the build. So we want to be able to catch issues as soon as possible. And as soon as possible is at the compiler stage, right? Let the compiler do as much as it can to help you. So where do warnings come in all this? Well, if you look at the GCC docs, it says that warnings are diagnostic messages, right? And they report constructions that are not inherently wrong, right? It's completely legal C++. But it suggests that you're doing something you probably didn't mean to do, or that you're about to step on a rig, right? There could be an error. So again, where does W4 come in all this? From Jason Turner's Best Practices blog, use every available and reasonable warning for you. And for us in MSVC, W4 means all reasonable warnings. And for GCC and Clang users, this effectively means WAll, WExtra. It's about the same. It's not going to be completely analogous, but it's about there. And WX is your WErr. So treat warnings as errors. So warnings are good. They're going to find us doing stupid things. So why warnings as errors then? And I think this Simpsons panel perfectly encapsulates why we need warnings as errors. So in one case here, it is very easy to ignore a warning. Exceptionally easy to ignore a warning, right? But the other reason is, let's just assume for a second that Homer is smart. And let's assume that Homer has verified that engine light is not telling him anything useful. There is nothing wrong with his car. But someone comes along later, Lisa, and sees that there's still a warning there. That next person does not actually know if that warning has been validated as being fine or not, right? They haven't actually actioned anything to validate whether that warning is fine. This is where warnings as errors comes in, because it forces that initial person, Homer in this case, to validate that it's fine, right? So warning level 4, warnings as errors, shifts the load from finding small issues, finding very silly issues, onto the compiler, right? Now, at CPPCon last year, Peter Muldoon had this really good talk on the code review process. And this particular slide stuck out for me because it's basically what I'm talking about here, right? Take it easy on your reviewers. Your reviewers will not thank you if you just hand them code that looks terrible and has obviously just got all these small little things wrong with it, right? Nobody wants to see that code. Let the compiler find it for you. And high warning levels are well-known good practice. Matt Godbolt did this fantastic talk at CPP on C in 2020, and he had this conclusion slide, and it's basically what I'm going to end with as well. Let the compiler help you up that warning level, and just, yeah, you don't have to worry about it. It'll find it for you. But things can be tricky. Raising the warning level on a project that's underway can be very hard, especially whenever that project is over 10 years in the running and is a very large code base. So the Sea of Thieves code base, so the game that I'm talking about today, it's about 30,000 odd C++ files right now, just the game, so not the engine underneath. We'll get to that later. And about 3.25 million lines of code. Right, that's just the game code. If you look at the engine, we're also adding to it as well. So we've got about 19,500 C++ files in the Unreal Engine version that we have, and that amounts to about 3.5 million lines of code. So we're dealing with 7 million lines of code here. Well, coming up to 7 million lines of code. And if you think that's a lot, it's not. If you get latest Unreal Engine right now and run the same query I did to get these numbers, you'll find that Unreal Engine, as of right now, is approaching 15 million lines of code. So we're half the size of what Unreal Engine is right now. So we're big, not that big. Right? So a very useful metric here is to see how much code we're writing in a year, right? Because that code has to be reviewed, and it is reviewed. So how much code are we reviewing in a year? So in the last year, so from February 2025 to now, we have made about 1,700 new C++ files, and that amounts to about 270-ish thousand lines of code just in Sea of Thieves. And this makes a lot of sense because I gave these same stats last year, and last year we had just under 3 million lines of code. And we'd been in development for about 10 years at that point. So yeah, writing about just under 300,000 lines of code per year, it tracks. Makes sense. And we are also adding to the engine as we're doing this. So 161 new C++ files and about 26,000 new lines of code there. So this is all being reviewed. We want a nicer reviewing experience, and a nicer just a code base to work in general. So the first thing we're going to ask ourselves, how much pain are we in for? So what is our current warning level? And the nice thing is, we're already at W4, so I got quite happy about this. I quite like the bottom comment, right? Back then, Unreal Engine didn't really work with Clang, so they just turned off warnings, just let it go. But right now, it's very good with warnings. This code no longer exists. But anyway, I'm very happy. We're at W4, right? So I instantly just made a plan of action. So the first thing is just fix all the warnings in the editor, right? We know about all the warnings at this point. So we can just easily just go and fix them, right? If you don't know what the Unreal Editor is, it's effectively the tool that any Unreal Engine game is just making all of their development iteration in, right? You're doing everything in the editor. You're not really doing much with client and server unless you are doing performance profiling or you are fixing a specific bug. But most iteration on development features will be done in here. So that's why we're doing it just for the editor at the start. And then we're going to slap on warnings as errors, and hopefully nobody will then turn that off so they can let more warnings in. And then step 3, just rinse and repeat for server and client. Just clean everything up after there. Now, this is all I needed to make code reviews better. So most of this talk will just be us reviewing some code and seeing if the compiler can do better than us. So code review number 1 then. So this is an opaque handle. And all it does is whenever you construct one, it calls this function generate new ID. We don't know what it does, right? You're in a review scenario here. Your context is literally just this code, this diff. And we have a getter function, and it returns an ID. And you might be looking at this and assuming, possibly, that the ID is a UN32. It's not. It's a UN64, right? So this could be an easy one to miss, where you're actually you're doing an unsafe conversion, right? You're losing data here. And You can find this by enabling warning C4244 or W conversion. I don't think you actually get this with Clang and GCC with all and extra. I think you actually have to do W conversion as well. But this will find a huge amount of very silly mistakes. So would recommend turning this on. Now, there are a number of ways to address this. The first fix is just to silence it. You could do a cast if you wanted, but that's not really going to address the actual underlying issue. You could make the person just store that ID as a 32-bit integer, but you're just shifting the problem there onto that generates new ID function, right? We don't really want to go out and look at what that's doing yet because it's an easier code review process if you can validate at the point that the code is written, right? In that context, that local context. So that's also not great. So obviously, the fix is what we all thought it would be. Just return it as a UN64, do the right thing, right? So next then, so we're going to take this in stages. So we have a forward declared enum. We make a struct. We define a struct that has a member of that enum. We then define the enum. And then we return the size of that struct. Right? I'm going to ask for a bit of audience participation here, but who here thinks this will even compile? I'm getting like 10 hands. Any version. Okay. I will tell you right now, this will compile on MSVC, but there's a straight up error in Clang and GCC. Because they're sensible. In MSVC, what it'll do is assume that that forward declared enum is 4 bytes in size, and then assume that struct A is 4 bytes in size as a result. But obviously we can't know that until enum is defined, which happens after the definition of struct. This makes no real sense. This is even the case if you put a char in here. So if you define my enum as having an underlying type of char, MSVC will still run this and it'll return 4. Because obviously at the point of definition of A, it still assumes that it's 4 bytes in size. It doesn't actually know the size. This can lead to really interesting and hard to track down bugs. Thankfully, there's a lovely warning for that, C4471. There is no associated warning in Clang and GCC because, as I said, straight up error there, and rightly so. Another point to point out is that bottom line. So the warning is off by default. That is incorrect, slightly. It's off by default if you are compiling with MSVC C++, so permissive C++. If you're compiling with standards conforming C++, it will be on by default. So whether this is on or not depends on another flag, which is slightly annoying. Now, you can fix this by just putting the underlying type as part of that forward declaration, but I would say that's very silly because it's an enum. Why should we be forward declaring an enum? You're not getting anything, just include the header with it. The reason that we were doing that is because in the version of Unreal Engine we had, they like to hide little very core enums in very large headers. And sometimes we didn't want to include that entire header. So what you just do there is just refactor the code so that the enum's in its own header. Now, function signatures. So in this case here, we have a function signature which takes in 2 floats and an int. And all we're going to do is we're going to take in a handle to a DLL, or a shared library, and we are going to ask that DLL or shared library for a pointer to the myfunc function. And we know that this function will take in 2 floats and an int. So we cast it to that, and then we return the result of calling that function. Now, if I see this in a code review, I'm not happy because I see reinterpret cast. And reinterpret cast almost always means you're doing something you shouldn't be doing, and it's undefined behavior. So this is forcing me to have to go and look at why you need reinterpret cast. It's forcing me to go and look at what get proc address is doing. So let's have a look at that. So it returns a far proc. What is a far proc? A far proc is a pointer to a function that takes in 0 parameters and an int pointer. Ignore the far bit, that's ancient history, we don't have to care about it anymore. So what is an int pointer? It's basically the same as std int pointer, so it's just a signed 64-bit integer. It is not a pointer to an int. Now, obviously, this function can return you the address to any function. It does not need to have this function signature. So this is just a very silly thing, and is forcing us to get an error warning for no reason. Now, we have a compiler warning for this, so C4191. It'll find whenever you're doing conversions from one function pointer signature to another. And this is quite useful, right? This will catch you doing very silly things. And you can get into a lot of bother whenever you're trying to call a function with too many or too few parameters as a result. And this is actually off by default, but Unreal Engine actually enables this explicitly. And I think it's a good decision to do that. So if we could have nice things, and we could fix other people's code, I would just make this a void pointer, right? It's right there in the name. It's a proc address. It's literally an address. It should just be returning a void pointer. There's absolutely no reason it should be returning a pointer to a very specific function signature. But we can't have nice things. So what we have to do here is what Gabby was talking about, right? We have to suppress, right? We have to sandbox the call to this just by disabling that warning and then enabling it. It's the best we can do. We can't change code that we don't own, but we can at least call it out, and this is now part of the code itself. Now, the question is, are we done? Because I've got a clean build, and we are 24 minutes in. I've got a lot more time. But the thing is, I'm very dubious about this, but I continue on. So I slap on warnings as errors and carry on to the server. It seems to be fine. So this is server-only code. Just want to point that out. So in server-only code, we're going to do some teardown here. And the first thing we're going to do is do some unregistering of events. And then we're going to do this bit of defensive programming. Right? We're checking to see if we are on a dedicated server. That's the intent here. And we're going to do an early return if we're not a dedicated server. And then we're going to carry on and do more teardown. To see where the issue is here, let's have a look at what dedicated server is. It's an enum for an eNet mode. So this is basically just describing this procedure's role in the architecture of the game. So you can have a standalone game, so that's your single-player games. And then you can have a dedicated server and client architecture, and then you can have a listen server client architecture as well. Now, you might be expecting maybe get role returns one of these. It does not. It returns a different enum. It returns a very related enum, but still different. So this is a net role, and this is basically saying how much agency or authority something has over its own data. So on the server, this is always going to be authority, because we want our games to be server authoritative. So what that means is we are comparing the value 3 with the value 1. This will never, ever get past this point in code. This is always going to do the early return. So we were getting a huge amount of teardown logic that was never being executed as a result of this. Thankfully, C5054 comes along, or deprecated enum compare, if you're on other compilers. This is actually quite a new warning, only for C++20 and up. Came in with paper P1120, and I actually talked about this in my last year's talk, because this came up a lot, and I fixed a lot of the issues around it. But warnings are very easy to ignore. Nobody was looking very cautious. Nobody was looking very closely at the build log of a shipping server. So yeah, very easy to ignore if you don't have warnings as errors. So the fix here is just simply don't be so defensive. We know this is only existing on the server. We know that, so we just get rid of it and just carry on. And we get some nice actual teardown logic now. And again, I'm faced with this clean build. I'm running out of material at this point. So I'm still very suspicious, though. But I slap on warnings as errors. And at this point, I'm now going to question that suspicion. I'm going to stop what I'm doing. And I'm going to ask, am I actually at this point for server and for editor? And of course, the answer is no. Of course not. That wouldn't be fun. Here's where the fun begins. This header is included in every translation unit in every Unreal Engine translation unit. This header disables over 60 warnings, very explicitly. And if you think this is us just putting this in to make our lives simpler, no. If you go and look at latest Unreal Engine, that list of disabled warnings is identical. Identical. Now, they have re-enabled some warnings in the last 10 years, but not that many. There's not much difference between this header and ours. And I just want to harp on this bit. This affects every Unreal Engine game. Every one. So we're talking about your Fortnites, your Final Fantasies, your Gears of Wars, your Rocket Leagues, your Sea of Thieves. All of them. Every one of them has this issue, and every developer is having to deal with the fact that these warnings are all disabled. And it gets worse, because that's not the only source of disabling warnings, right? We can disable it from the build system as well. So there's even more there. At this point, I'm despairing, right? So there's a bit of despair going on. But, of course, we rally and we make a new plan. It's a bit more complex, so we'll go through it with a bit of pseudocode. First thing I'm going to do, disable warnings as errors. Why? The reason is because if you have warnings as errors enabled and you're going to re-enable a disabled warning, you're not going to get every hit of that warning. Because if you hit a warning, it's not going to generate any object code, and anything that depends on that object code will therefore not be generated, right? So we want a full list of all of the hits from a warning. So we disable warnings as errors right now, just temporarily. And then we're going to go through every disabled warning, enable it, and build it, and hope it succeeds, right? In the happy case, there's no issues, and we can just re-enable it and carry on to the next one. But in the unhappy case, we need some heuristic, right? We need to know if we should fix all the issues brought up by this warning, because right now we're in the land of pragmatism. We can't fix everything, unfortunately. So if this comes back as true, then we're just going to fix all the issues in the warning and re-enable it and be happy. Otherwise, we're just going to ignore it, right? We're just going to accept this is now disabled and we can't do much more about it. So disable it and then carry on. And then once we're done with everything here, we can then re-enable warnings as errors and do some other things. Now, the heuristics of should fix comes down to two main factors. The first is the number of unique warnings hit. Because if a warning is being emitted from the header, every translation unit that includes that header will get the exact same warning. So you might have 8,000 warnings being emitted, but you might only have to fix up maybe 20 places, right? So we want an actual good measure for how much work will be involved to fix all the issues for the warning. And the other axis is usefulness. And you might notice that usefulness has no units, because it's very vibes-based, right? It's down to what your project needs, requires, how you feel about it, how that warning makes you feel. So this is going to be very specific to you yourself. Now, everything above the curve, we should probably fix it. We're going to get some bang for buck. We're happy with the trade-off we're going to get there. And then for anything below the curve, probably should ignore it. It's probably not worth the effort. Okay, then. So I am once again going to ask you to review some code with me. On to code review number 5. So in this case here, we have just a very simple struct. And we have ordered our members by alignment, right? So we're doing our best here to not waste space. Right? That's the whole point here. And if you look at our struct layout, we can see that the best we're going to get here is 3 bytes of wasted space because of padding. But we're in the games industry, and we don't like that. So sometimes we pack stuff, right? And there's about 100 instances of this in Unreal Engine. And that gives us a better struct in some ways. There's only 1 byte of wasted space. But you can see here there's unaligned accesses now, right? Because we're accessing your uint32 on a 2-byte boundary, not allowed. You're accessing your uint64 on a 6-byte boundary, also not allowed. So I initially thought, yeah, this would be a good thing to not do. So this is where compiler warning C4121 comes in, and it'll find this issue for you, which is nice, right? But I want to ask the question of how much of an issue is this really? So I went off and looked, and Daniel Lemire has this fantastic blog post from 2012, right? So it's 14 years old. And in this blog post, he concludes it's actually not that much of a problem for speed at all. And this is a very active blog post. I think that the comment section is now larger than the blog post itself. And people were still trying to reason and argue with him up until last year. And he's always rebutting people, and he's still sticking by the fact that this is no real issue for performance. So I'm going to believe that. And for a second opinion, if you go and look at some Linux kernel development, they have this macro with efficient unaligned access, and that's defined as true for x86 and ARM64 and some others, right? So in most cases of the hardware that you're writing for, at least for us in games, right, it's all x86. So for us, it's fine. But the guys at PVS Studio are very quick to point out this is very much undefined behavior. And I would like to limit the amount of undefined behavior, even if it doesn't have a performance impact. So I thought this was still quite worth fixing, and I was hoping there wasn't going to be many hits. And I got my wish. There was none. Not a single one. And the reason for that is because we order our structs from largest alignment to smallest. And if you do that, you'll never an issue due to this. You'll never get the unalignment thing. So top tip. Okay, code review number 6 then. So we've got some core library in a source file in the translation unit. And we're just going to define a member function. And we're going to offload some of the computation for this member function to some helper. And we define that helper as being a static global function. So it's got internal linkage. This is great. So it's private to our translation unit. This looks good on first review. Now, through some iterations of this review, you find that you don't really need that logic to be called. It is very simple. Well, at this point, what do people think we should do? Right? We don't need this call anymore. What should we do? Well, you could. What's better than commenting out? Throw it away, right? You've got version control. Yeah, you've got source control. You don't need that, right? If you need it, you can go back and get it later. So you should. But the thing is, most people won't do that. They won't, right? So this function will just lie there and rot. And that's where compiler warning C4505 comes in. And it'll find any unreferenced function for you. And people might say, but what's the point, right? It's not going to cause any performance issues. It's not going to reach your binary, so who cares? But I care because it makes sense for the review, right? If you don't need that function anymore, you should absolutely remove it. And that gives more context for that review. It makes the review process easier. So, yes, the thing we should do here is just delete these together. They're part and parcel. So that's one good use of this warning. There's another potential good use. Say we initially had this global function, this global static function, but it was in a header, right? If we have that in the header, what happens to every CPP file that includes it? Sorry? Exactly, right? You're going to get a copy of that function in every translation unit that uses it. What you actually meant to write here was inline. You meant to say, I have a global function, and everybody who includes this header can use that function, not a copy of that function. So I thought whenever I saw this, ooh, we're going to get some binary size improvements. So I thought it was really useful. So I went off and fixed it. There are about 280 unique hits of this in our code base, so not that many in the grand scheme of things. So once I did it, I went off and I went to see if there was any actual binary size savings. And there was. A kilobyte. A whole kilobyte. So not really. Just to explain how little a kilobyte is, Unreal Engine has this class called actor, right? So that's the game object. You have thousands of these in a scene in your game. That's over a kilobyte in size. We didn't even save enough room for one of these, which is a bit terrible. But the thing is, I will point out though, the reason we only got a kilobyte from this is because we use link time optimization. So even with link time optimization, there were still improvements to be found from this warning, right? That link time optimization, it didn't find everything. It found most, to be fair. It probably found 99.9%, but it didn't get everything. So that warning's useful. Would recommend. Okay, so this by itself, it's not inherently wrong, but it could be wrong. And it could be wrong now, it could be wrong later, and you don't know because there isn't local reasoning to have. So the issue here is we've got a virtual interface, so you're probably going to have a pointer to this A, and you're probably going to have that pointer pointing to different dynamic objects that inherit from A. And if you try to delete an object of that type from that pointer, it's undefined behavior, but in reality what you're going to get is the derived classes destructors are not going to be called. So what we should be doing here is making that virtual, right? And there's a warning for this. So C4265, or if you're inclined, there are a couple of warnings, and they're technically, I think, better. So the first of those is delete non-virtual destructor. And the reason I think they're better is because in Clang and GCC, they will only emit a warning at the point of deletion. Right? And on MSVC, this will find the issue at the point of definition of the class. So it's being very aggressive about how it does this. And for every interesting feature, I always think there's an old new thing blog post about it. Right? Raymond Chen has a fantastic blog, and he has a couple of blog posts on this. And it's all about the fact that there are a few instances in some core Windows headers that will emit this warning, and that's probably the reason it's off by default. But I think it's useful, and actually modern Unreal Engine has this enabled now explicitly, so I think it's probably worth it. But I still wanted to understand how much of an issue is this. So this is our setup. We have a B, inherits from an A. B has a destructor, and it's going to say hi BeCPP on destruction. First thing we're going to do is, let's just see raw pointers. So we create a new B, return it as an A pointer, and then we're just going to delete the thing. In this case, as I've already explained, this will not print out hello BeCPP because we're deleting a B through an A, and A does not have a virtual destructor. So we do not get that destructor being called, which is a problem. What about unique pointers, right? Smart pointers are better, but the thing is, unique pointer has its deleter as part of the type signature. So we're getting the same problem here. So this is still also wrong. But for shared pointers, this is fine, because shared pointers type arrays their deleter, so the deleter is actually captured at the point of creation, so in the make shared call here. So you're actually getting a deleter that will call the destructor of B. So you won't get the issue here. And in Unreal Engine, most of your deletions is done through the garbage collector. Yes, we have a garbage collector, and it is terrible. And we also have shared pointers. Everything else is basically a shared pointer. We have very little unique pointer usage or raw pointer usage as well. But I thought it's still worth doing. I did wrestle about this. It's very much on the line. And the reason I said this is still worth doing is because it would be picked up by code review, and it's part of our coding guidelines that you should absolutely have a virtual destructor if you have a virtual interface. And if we are going to catch it at review, let's just let the compiler do it, right? There were about 250 unique hits of this. So again, not that many in the grand scheme of things. Now, code review number 8. So we've got a struct. It's got an unsigned integer. And we've got a function. It's going to take in one of these structs. And then it's going to compare that unsigned integer with a signed integer. The issue with this is unsigned integers and signed integers have very different ranges of values. So it doesn't really make sense to be able to compare them, because you're going to get very different results if something is negative, right? This can be found by warning C4389 or sign compare. And this is really well-known good practice to not do this. Sandor Dargo has this 3-part blog post all about this. So why you want to enable this, and then some of the most common and also some of the most hideous violations that you can come across because of this. You absolutely want this warning enabled. So I thought, yes, let's go ahead and enable it. But then issues started to arise while I was going through some of the issue sites. We use a lot of bit fields in Unreal Engine. A lot of them, just to get efficient space usage for bools. And unfortunately, this code will now emit that warning, even though an unsigned int with 1 bit, like a bit field of that there, has the same range as a bool. And Clang and GCC also don't emit a warning for this code either. And another reason why I think this is a bug is because if you try to compare it with a constant expression, it also doesn't emit it, right? So if I see a bug, I always like to report it, right? Compiler writers are never going to be able to fix things if you don't report where things go wrong. So if you want your compiler to get better, just report things as you see them, right? So that's a link to the bug. If people want to get that warning to be a bit better, feel free to go and upvote it. So unfortunately with that, my analysis goes down. It is beyond useless for us. We don't want people to have to static cast everything just to set some bools. That's very silly. So that's something we did not fix. Now, this is the fun one. Yes, I've left enough time for this, right? This is the fun one, right? This is the final one. Put your hand up whenever you see the problem. It's called get current token and advance. I'm going to wait 5 seconds. Sorry, I can't hear you, but I will just save everybody. We are certainly advancing. At no point here are we actually returning the token. We need that return. Right? That's always going to return null pointer until that point. Warning C4189, or unused variable. This will catch so many sins in your code base, so many horrendous things. If you've got this enabled already, well done. If you don't, definitely go back, enable it, and see all of the terrible things you have in your code base. And just to show you some of the cases that I found, let's just go through some more examples. This is fun. That's a big memory leak. So it's a static function, and it just allocates some memory and then does nothing with it. Whenever I first saw this, I got quite excited because in the games industry, I don't know about others, but there's always this mythical stash of memory that some tech director is going to break out in an emergency whenever you need a ship and you don't have enough memory. And I thought I'd find it with this. I thought, yes, that's where it is, but it's not, unfortunately. This is part of a test harness for testing for memory that's not deleted, not cleared up, right? So unfortunately, my happiness subsided, but still, that's going to find some really daft things like that. The second is, this class was definitely written pre-static assert, right? So in this case here, they just wanted a compile time test to make sure that a template type that's come in inherits from the class's template. Pretty simple, but we're in the land of C++11 and beyond now, so this can just be a static assert, right? We can just do a static assert, or because we're in the land of C++20 and beyond, that can be a concept, right? Much cleaner. This is a fun one. This was littered all over our testing framework. So we have a mock here, we're creating a mock, and then we have a function called test not null or abort. And we give a lovely error message telling us what the intent is for this function. You won't see us passing that mock wieldable into this function. Right? So how are we validating that it's not null? Well, we're not. Right? So this is a very good example of an interface that breaks Rule 55 of the 97 things every programmer should know. So this rule is written by Scott Myers, right? And it's very simply, good interfaces are easy to use correctly and hard to use incorrectly. And that was very much a function that was easy to use incorrectly. Super easy. The point at the bottom here is very important as well, right? Above all, right, remember that interfaces exist for the convenience of the user, not the implementer, right? It can be very complicated to implement it. Just go and have a look at std_vector or variant if you really, really want to challenge. These are very complicated things, but they make for very good interfaces, very easy to use interfaces. So the actual fix here is going to involve having a look at this function template. So it's very simple, takes in a message to print out whenever it goes wrong, and the pointer you want to validate, and then you just validate the pointer. If it is null, then you throw an exception. So that's how the test is exited, right? But for the lazy people who don't want to give a message, we provide this convenience version. The problem here is it's taken in a pointer, any pointer, and a string literal at all points is a valid pointer. So that's where we're getting to this point. You can pass in a string literal, and it'll just say, yeah, it's fine. So that's very silly. So the fix here is to go again, use a bit more concepts, and just not allow any string literals to be passed in. Right? And that, whenever I applied that, there were so many tests that were doing this. It was quite fun. So again, fantastic warning to have enabled and found a lot of issues in our code. And this is the last one. This is a performance leak. So we're doing a very expensive query, and then never using the result. Now, the compiler or whatever, it can't optimize that out. Not possible, right? Because it doesn't know that there are no side effects. It can't know that. In some cases, it can, sometimes, but in most cases, no. Like if there's an allocation, so how does it know that you don't care about the allocation? It doesn't. So the best thing you're going to do here is just don't do that, right? The best code that you write is the code you don't. So all of this together means that this warning is absolutely fantastic. We want this. But unfortunately, whenever something's really good, it can be really hard to fix. Unfortunately, whenever I compiled this, there was over 9,500 hits. That's an order of magnitude, almost 2 orders of magnitude, larger than any other warning I came across. So unfortunately, I haven't actually done this, but it is very much the final boss. Right? I will get this fixed. So yeah, start off with 9,500 hits of this. And we're currently down to 5K. I will get there, I promise. But yeah, that's basically everything. So I just want to wrap everything up before leaving for Q&A. So how hard is it? That's the question. So just to slap on warnings as errors at the start, wasn't that hard, right? There's only 105 instances of anything, and that was over 10 reviewed CLs. So I got 10 other people to review that code. Warnings there for the server. Only one place. It was just that one enum comparison, right? It was a fairly interesting bug and was actually stopping some key code from running, but it only found one thing. That's fine. For the struct packing, yeah, there was nothing there. All I had to do was just enable the warning, and that was it. Fairly simple. And there's a bit of a leg up for unused function. By 280 individual changes there over 11 CLs. So 11 reviewed changeless. And for virtual destructors, a bit fewer, but more CLs. The reason there's more is because whenever I got to the end of them, and then I do a remote run, I would find that somebody had violated that warning. Right? Somebody had submitted code that was doing the bad thing with the virtual destructor. So this was actually found to be quite useful. Actually, it was actively finding things. And then there's a whole rake of other ones that just aren't worth talking about, and I didn't have time. So I just want to say warnings are useful. And if you watched Gabby's talk and you thought it was really good, it is good, right? So he's basically just talking about everything I want to do. I just don't have profiles yet. We will have them. They find bugs. They find unnecessary code. They find performance issues. They find those very silly performance leaks. And with all this together, with warnings as errors, they make code reviews easier, right? You don't have to see all of that code in code reviews anymore. You don't have to know to look for those arcane things because the compilers already find it for you. So they make code reviews easier. But, there is a but. Yeah, there can be more hassle than they're worth, right? And that's why we need to be pragmatic about these things. That's why that there's suppressions, right? You can suppress your warnings. Sometimes that the warning is maybe not doing what you want it to do, or there's a bug in it, right? And you submit your bug, and hopefully it'll be fixed. But yeah, sometimes you can't enable all the warnings. And unfortunately, usefulness is usually proportional to the number of issues that you find, right? And that makes sense, because it's pretty useless if it never finds an issue. So, unfortunately true. And also unfortunate is the number of issues are going to be proportional to the size of your project, which could be large. And one final thing, I have a call to action. Just enable more warnings, right? Go home, look at the warnings that you don't have enabled in your projects, enable them, and see what terrible, terrible things you have written last week. And that's it, really. Q&A time.
Hello, is this thing on? Yes, okay, cool. So the first instance with the enum, the
yes.
C-style enum, wouldn't all of that be avoided by using C++ enums instead of C-style enums?
Absolutely.
Right. So if you're writing new code, would you then say, oh, we're just going to use C++ enums instead of replacing?
Absolutely.
Okay.
But we're not in that world. At least I'm
so
not.
So this would apply to existing code, and you want to make sure that
yes.
that's good.
100%.
Okay, that makes sense. Cool.
Absolutely.
Was this only Sea of Thieves, or was this with Unreal?
Oh, with Unreal, yeah.
With Unreal.
Oh, absolutely.
Then going further with Unreal, how many of these warnings and bugs did you find in Unreal that you then passed on and got fixed in the meantime? Did that happen a lot at any point?
So unfortunately for Sea of Thieves, we forked 10 years ago. So the stuff that we would put through probably wouldn't matter anymore. One thing I did do was I tried to see how many unique hits of that last warning, so unused variable, were in modern Unreal Engine with the Lyra project. There's 5,000 there, so they're doing all right. It's still a lot, right?
Yeah. Which specific version of Unreal does Rare use right now?
For Sea of Thieves, it is a heavily modified 4.10.
And do you have your own scripting on top, or do you just use the normal C++ for scripting?
I would just use C++ and then blueprints for designer hookup and stuff. No, we don't use anything custom like Angel script or anything like that. No.
Are you monitoring the warnings in CI before fixing them, or not really?
No, we could do that, But then you have to do the whole thing of validating those and auditing them from time to time to make sure that they're worth it. We do that in some cases for other audits. For like asset audits, we'll do that because sometimes you want them through. But as far as I'm concerned, the warnings I've talked about today, these are things that we absolutely should be catching at code review time, and they shouldn't be allowed through. But we're human, so of course they are going to be let through. Right?
Yeah, we just set it up that if it goes up, you get a warning during the review, and that catches the issues without having to fix them all. But
it could. I want to live in a code base that doesn't have these issues. Or at least you address them. So go back to the Homer thing. We want people to have explicitly addressed them. Right.
Hi, thanks for the talk. Just an extra word of advice. I've also been in battling warnings already my entire career. I would suggest people to also use multiple compilers.
Absolutely. Yeah.
They see more things. And once you're happy with your compiler, activate static checkers like CPP check and clanked ID. These are just stupid programs which are having your back. So it's not a debate with your colleague, I like it green, you like it black. No, it's a stupid machine who says, I disagree with you. And unfortunately, machines typically are right and humans are wrong. So take advantage of that. It's called computing.
I would definitely, I would say that's very good advice. We just need to get to the starting line before we get to static analysis.
Hello, thank you for the talk.
Thank you.
How do you build in the time to do this work? Because, for example, I've also been dealing with all of this over the last 5 years at my place.
Yep.
And it's always very hard to balance. You have a game to ship, you have features that people have requested with, we have this tech that we have this work that we want to do.
Yeah.
It'd be really nice to do it, but it's really hard to justify doing it sometimes.
Yep.
How do you convince the people who are in charge of deciding what time gets spent on what to actually do this?
Yep. So I had, I think, a 5-minute segment of my previous talk answering that exact question. It basically comes down to priorities and how you can convince people to accept that's a good priority. So you need to have, like, why is this a good idea to do? And from what I've heard from this symposium already, it seems that we are wanting to head this way. We want to be using our tools a lot more. So it was an easy sell. And to more concretely answer your question, at Rare, at least in my team, it is very much encouraged for you to spend half of your Friday, or another half day if Friday doesn't suit you, doing learning and development. And that's my learning and development. It's busy. It's my Friday fun time. It just takes one person, I think.
Yeah, let me add also a little word of advice to that. I think you should do that on a continuous basis, continuous improvement. Don't say, we're going to not write code for 2 weeks, we're going to go off and when we come back that warning is gone. It doesn't work like that. You're not productive for 2 weeks, but if you do it continuously, warning X 1,000 issues. If you do it with your team, at the end of the next sprint, it's 900, and so on and so on. And each time you continuously are improving your code base. And then you can have a Friday session where everybody says, come on, let's do those final 200 this afternoon. And you will all feel good and go home. And that way it also brings a bit of joy because you know your code base is better than 1 hour ago.
Yeah. These are all tasked
step by step.
These are all tasked up in our ADOs, so people are free to go and run at them. What tends to happen is I do a bit of analysis, see which ones are worth it, and then I just task it up, and then people can take it and have fun if they want to.
Okay, I think, thank you, Keith.
Thank you.